Assalamualaikum and hi everyone. I'll be giving a quick briefing about the report. This report is based on a construction project that has already been completed, and it's focused on how the project was planned before the construction started. The main aim is to show how the project planning, site mobilization and resource management were carried out. To explain this, we prepare a work breakdown structure, a project schedule, a cash flow plan, and a step-by-step method statement for one of the main work activity. The report also looks at whether the project was feasible by identifying key planning and resource challenges by highlighting the lesson learned from the project. Overall, the report followed the assignment brief and fulfilled the requirement for bqs560 Project Management 1.
Now, for the first one, which is the project review, this project involved the building of 101 unit of double-story link houses. It is owned by W Property. To make things easier to manage, they split it into two phases, which is phase R2A with 47 unit and phase R2B with 54 unit. They are just building houses. They also setting up a T&B substation and guardhouse to make sure the neighborhood is safe and has reliable power to continuing their process. Okay, next one will be the project location. Moving on to the location, the site is in Nilai Impian Township in Seremban, Negeri Sembilan. It sits on a few specific land, which has a lot and already a part of major B development area. The best part about this location that it is already connected to a major road and infrastructure, which make it a very convenient spot for future homeowners. Onto the next one will be, which is the project stakeholder. Now let's look at who is making this project happen and possible. W Property is the employer, which is the one who funding and leading the project. Pembinaan Daya Teguh is the main contractor responsible for the actual building work. They also have a team of professional consultants, including architect for the design, engineer for safety, quantity surveyor to keep their cost and budget on track. And I will explain more about the budget at the S-curve in the following video. Next will be the project scope. The scope of this project is quite broad. It starts with earthwork to prepare the land, followed by actual construction of the 101 houses of unit in Seremban. They also are responsible for the extras that make the neighborhood work, like building and the internal work, putting in drainage system to prevent flooding, and setting up the entire sewerage and water pipe network for the resident to ensure all of these components working properly and to ensure them to live happily. Okay, for this one, I will presenting 2 points, which is the project timeline and the project budget and constraint. For the timeline, they officially start on February 1st, 2023, and they have 18 months to finish their job, which brings us to July 31st, 2024. One thing to note that they have a very strict rule to follow. They operate under PAM 2006 contract, and all the vendors have to sign an integrity pledge. This means they have zero tolerance policy over any corruption and untechnical behavior, which will make their job more convenient and safer in the future.
Project scheduling is an important part of construction management, as it provides a structured framework to organize construction activities from project commencement until completion. It helps the project team visualize the overall construction process and understand how the project progresses over time. Scheduling also helps identify what activities need to be carried out, when they should be executed, and how long each activity will take, ensuring a smooth coordination among all project stakeholders. Project scheduling is essential to avoid common construction problems such as project delays and poor time control. Without a clear schedule, activities may not be arranged in the correct sequence, leading to delays in project completion. Scheduling also helps prevent overlapping activities and resource conflicts by ensuring that labor, materials, and equipment are allocated efficiently, improving overall coordination within the project team. The project schedule was developed based on key construction drawings, including floor plans, elevation drawings, section drawings, and roof plans. These drawings provide a clear understanding of the building layout, structure, and construction sequence, which are essential for identifying scheduling activities. However, highly detailed component drawings such as door, window, and sanitary details were excluded from the scheduling process. This is because such drawings are more relevant for measurement and costing purposes rather than for identifying major construction activities in project scheduling. The construction activities were identified directly from the selected architectural and structural drawings to ensure accuracy and relevance to the actual project scope. This approach helps avoid assumptions and ensures that the schedule is based on real construction requirements. The identified activities were then organized using a work breakdown structure, or WBS. By using WBS, the project was broken down into manageable sections, allowing the schedule to reflect the actual construction process and providing a clear foundation for further scheduling and critical path analysis. The objective of project scheduling in this project are to ensure that construction activities are identified and arranged in the correct sequence based on the project drawings. This helps ensure smooth and effective execution of the construction works. Project scheduling also aims to create a realistic project timeline by estimating appropriate durations for each activity. A master program in the form of Gantt chart is then developed to show the sequence duration and overlap of major construction activities. In addition, scheduling helps identify critical path activities that directly affect the overall project completion period. Finally, the project schedule serves as a basis for monitoring and controlling project progress during the construction phase. For this section, the construction activities were identified based on the project drawings and then organized using the work breakdown structure. This approach helps ensure that the activities reflect the actual construction process. The activities were grouped into major work sections such as preliminaries, substructure, superstructure, roof works, and finishing works. Organizing the activities using WBS provides a clear structure and logical sequence for the project. This list of activities serves as the foundation for developing the project schedule and for carrying out the critical path analysis as shown in Table 4.2.1. Microsoft Project methodology was used as the main tool to develop and manage the project schedule in an organized and effective manner. The software allows activities, durations, logical relationships, and resources to be entered in one system, making it easy to update the schedule when changes occur. In developing the schedule, activity relationship were carefully considered to ensure logical sequencing. Most activities follow a finish-to-start relationship, such as foundation works before column construction. However, start-to-start and finish-to-finish relationships were also applied where appropriate to allow overlapping activities and improve the overall project timeline. Next, the master program. For this project is presented in the form of Gantt chart developed using Microsoft Project. The activities identified from the architectural and structural drawings were used to develop the program and were logically organized according to their start date and end date and overlapping periods. The Gantt chart provides a clear visual representation of the project timeline, which helps improve communication among project stakeholders. It also the project team to monitor progress against the planned schedule and understand the overall construction sequence. During the construction phase, the master program serves as an important tool for time control and project coordination. Next, for the critical path analysis. This is used to identify the sequence of activities that directly determines the overall project duration, as shown in figure 4.5.1 critical path analysis. The critical path consists of activities that cannot be delayed without affecting the project completion date and therefore require close monitoring. For this project, critical path analysis was carried out using Microsoft Project by considering the duration and logical relationship between activities. The critical activities identified include foundation works, structural frame, wall construction, roofing works, and main finishing works. These activities are sequentially dependent, meaning each activity can only start after the completion of the previous one. Critical path analysis also supports decision making, especially when delays occur, as it helps the project team determine whether additional resources are required to recover lost time and ensure the project is completed within the planned schedule.
Hi, Assalamualaikum. So what is WBS, or we call as work breakdown structure? So WBS is a deliverable based method that break a project into smaller, which manageable component with the project goal at the center. It helps project manager to plan and estimate time and cost, also track deliverable and control project scope. WBS also improve communications among the members and stakeholders by ensuring everyone clearly understand the tasks, responsibilities, and project progress. So next is process of WBS. A work breakdown structure use a multi-level top-down approach to divide a project into smaller, manageable components. Each descending level provide more detailed grouping final deliverable into work package for easy control of scope, time, and cost. By applying the 100% rule, WBS ensure the full project scope is covered and support effective scheduling, budgeting, and project control throughout the project life cycle. This is a WBS diagram. So as you can see, there's preliminaries, substructure works, and superstructure works, and roofing works, and architectural works, and also the last one is completion.
Assalamualaikum warahmatullahi wabarakatuh. Okay, for this session, I will explain the initial capital requirement during the pre-construction stage. Initial capital requirement refer to the upfront fund need before any construction work begin on site. These funds are essential to cover early project expense such as consultancy fee for the architecture, engineer, and quantity surveyor. Site investigation work like soil testing and survey, authority submission and approval fee, as well as preliminary site setup cost. Adequate initial capital is very important because it ensures that all approval can be obtained on time and the project can commence without delay. In the initial capital is insufficient, it may lead to delay in approval, disruption to the project schedule, and increase financial risk at early stage of the project.
Okay, next one will be the project location. Moving on to the location, the site is in Nilai Impian Township in Seremban, Negeri Sembilan. It sits on a few specific land, which has a lot and already a part of major site the B development area. The best part about this location that it is already connected to a major road and infrastructure, which make it a very convenient spot for future homeowners.
Session 5.3 focuses on cash flow forecasting during the pre-construction stage. This stage involves estimating how much money is needed and when it will be required before construction activities start on site. Pre-construction cash flow forecasting is important because many costs are incurred early, such as contract documentation, design works, and site setup. Proper planning at this stage helps ensure that sufficient funds are available and reduces the risk of financial problems when the project moves into the construction phase. The pre-construction costs are divided into three main categories. The first category is contract, tender, and legal costs, which are required to formalize the project and meet statutory requirements. The second category is design, survey, and technical costs, which support technical preparation before construction begins. The third category is early site setup costs, which involve preparing the site to allow construction works to proceed smoothly. Based on the cash flow forecast, the total estimated per construction cost for this project is 575,700. The largest portion of this cost comes from the early site setup works, such as temporary fencing, site offices, and welfare facilities. This shows that significant expenditure is required even before physical construction works begin. The pre-construction cash flow is distributed over a 3-month period. In the first month, expenditure is relatively low and mainly involve contract and initial design work. In the second month, costs increase due to authority approvals and early site preparation. The highest cash outflow occurs in the third month when major site setup works are completed. This stage distribution helps reduce financial pressure and improve cash flow stability.
Okay, now let's continue and move on to the S-curve of our project chosen. The curve starts with a slow tail during the first 4 months. This represents their startup phase, where spending is lower because they're focusing on site setup, insurance, piling, preliminary work, and so on. The middle of the graph shows a step climb between month 5 and 12. This is their most intense period because phase A and phase B overlap here, and spending jumped to 2.8 million. This is where the 101 houses are physically rising from the ground. Finally, the curves levels off toward the end. This heavy construction is finished and costs drop as they are focused on final detail like painting, piping, and landscaping. Following the shape of S-shape ensure that they manage to have their resources eventually and reach their final goal of 29.5 million on their schedule, which is at the end of 31 May 2024. So that's it from me. Assalamualaikum warahmatullahi wabarakatuh.
Hi, so next is financial and mitigation strategies. So managing financial risk in the pre-construction stage is crucial due to high upfront costs before progress payment begins. So contractors should prepare a detailed cash flow forecast to covering tender fees, bonds, and insurance, and also mobilization costs and early procurement to anticipate liquidity gaps. Contingency allowance should be included to address uncertainties such as design changes, material price fluctuations, and regulatory requirements. Securing financing in advance, such as overdraft or short-term loans, ensure early financial commitments can be met. Negotiating favorable contractual terms, including advance payment and reducing retention, and improve early cash flow. Early engagement with supplier and subcontractor through fixed pricing or credit agreement further enhance cash flow stability and financial control.
Okay, right now we be moved to Chapter C, which is a method statement matrix. The method statement matrix provide us a structure and systematic overview of how construction activity will be carried out in this project. The method statement focus on work below lower flow finish, or WBFF, which cover a substructure work before the substructure begins. Okay, next, activity description and scope. The scope of this method statement cover all construction work below ground level. All activity are carried out according to approved drawing and specification to ensure structure stability, quality workmanship, and compliance with safety and environment requirement. Proper planning at this stage help to reduce construction risk and potential delay. Okay, the sequence of work start with site clearing and setting out, followed by excavation for formation level. After that, link concrete blending is placed, reinforcement is fixed, and forward is installed. Reinforced concrete is then cast and compact, followed by curing and forward removal. Finally, ground slab construction and soil treatment work are carried out before moving on the superstructure stage. Okay, right now we go for research requirement, machinery and tool, and health, safety and environment consideration. Like we can see, for research requirement, the project involves manpower such as a site supervisor, steward, general labor and machinery operator. The main material include concrete grade 50 and grade 30, reinforcement bar, timber formwork and dam-proof membrane. Equipment such as a concrete operator and bar cutting and bending machine are also required to support the construction activity. Okay, for machinery and tools, the main machinery used in this work include excavator for excavation, dump truck for soil disposal, concrete mixer truck for concrete supply, and concrete operator for compaction. Bar cutting and bending machine are used for reinforcement work, while hand tool are used for forward installation and finishing work. For last this page, health, safety and environment consideration. In terms of health, safety and environment consideration, all work are required to wear proper personal protective equipment such as safety helmet, safety boot, glove and relative vest, safety snatcher, barricade and daily toolbox meeting implement on site. Environment measure include proper disposal of excavate soil and control application of anti-termite chemical. Emergency equipment such as first aid kit, fire extinguisher are also provided on site. Okay, right now we move to next slide, method statement matrix. This slide shows the full method statement matrix for work below lower flow finish. Table summaries each activity, including the quantity, plan and machinery, manpower, material, output and duration. This matrix help ensure that all work are properly planned, resources are allocated efficiently, and the construction process is carried out safely and systematically.
Thank you. Right now, I'll be explain the challenges in planning and resource management. This project faced several challenges in planning and resource management, mainly because of its large scope. It involved the construction of 101 double-story house, a TNB substation, a guardhouse, and various infrastructure works, which made planning more complex. With so many work components happening at the same time, detailed scheduling and strong coordination were needed to avoid clashes and delay. Another challenge was the complex cost structure. As the project was divided into 12 bill numbers, this required accurate planning and continuous cost control throughout the project. In terms of resources, managing labor, materials and plant was also challenging. Issues such as labor availability and productivity, material supply and price fluctuation, and equipment scheduling had to be carefully managed. Supply chain disruption and emergency risk could also affect material delivery. Lastly, strict compliance with the vendor integrity pledge and vendor code of business conduct added further planning risk, as any non-compliance could lead to contract termination and major disruption to the project. Right now, I will explain the lesson learned from the case study. The first lesson is that the ethical conduct must be a core organizational value. The enforcement of the vendor integrity pledge and code of business conduct shows a zero tolerance approach to corruption and bribery. Next lesson is the importance of detailed risk management planning. Clearly define project scope, phases and infrastructure allow more accurate forecasting. Requiring vendors to have business continuity plans improve resilience against unexpected disruption. The final lesson is the importance of strong governance and documentation. Comprehensive documentation ensure accountability and reduce misunderstanding. Conflict of interest disclosure promote integrity and trust in vendor relationship. In conclusion, the study applied key project management techniques to a real housing development project in Nilai Impian Negeri Sembilan, with a focus on the pre-construction phase. Important tools such as the work breakdown structure, Microsoft project scheduling and critical path analysis were used to demonstrate effective control of time, cost and resources. The feasibility analysis confirmed that the project is technically viable, financially acceptable and contractually compliant with the PAM 2006 framework. The project also highlight key challenges including planning complexity, coordination of resources, cash flow management and ethical compliance. The overall this report demonstrates that strong earlier stage planning, support by effective risk management and governance is essential for project success and provide valuable lesson for future construction managers.